the year, we have done a lot of these types of hypothesis testing problems. We've come to the conclusion for a lot of different varieties, and so we'll be pretty much grateful that the conclusion for a two-sample Z or T test follows the same template that we've been using all along. In the conclusion, you're going to need three parts. You're going to need evidence. You're going to have to make a choice, and this choice is either to reject or fail to reject the null hypothesis. And then we're going to have to put that choice into the context of the problem. So let me just remind you that evidence is saying if my p-value, that is to say the probability of seeing the difference that's occurring in this particular problem, is less than or greater than our alpha at whatever value we use. But 0.05 is of course our default. So remember, if the p-value is less, if the probability is low, we are going to reject the null hypothesis. And in this case, the null hypothesis is that the two means are equal. The two populations have the same average. But if the p-value is greater, that's saying that the result we're seeing isn't rare enough to cause us to disbelieve our null hypothesis, so we would fail to reject the null hypothesis that the two are equal. So we are either rejecting or failing to reject. So the context of this, it's kind of hard to talk about context when we're just talking in general terms, when we have no context to speak of. But the context would be, if we reject the null hypothesis, we would say, it seems the two means are different. And of course, you would use the topic that we're discussing in the particular problem when you said that. But in general terms, it seems the means, the population means, I should say, the averages are different. Or, if we fail to reject, we might say, there's not evidence to suggest a difference. There isn't evidence to suggest a difference. But again, this falls into the realm of conclusions that we've been doing for, well, 2 chapters now. So we should be pretty good at this.